right, and we're back. So for question number 3, what you're trying to accomplish is this graph similar to what Dr. P has on slide 22. So what we're going to do is we are going to input our data in terms to make a graph similar to this. I did speak with him about, if you notice that 1 dB/dB line, unfortunately when you're making the graphs on a computer, you can't actually do that, at least with the newest Microsoft Word. What it actually has you do is it provides a linear line, but not linearly with the parameters that he has. So you can create a line, but it's not what he wants. So he told me that we can write it in pencil, and I'm going to show you how to do that as well. So what we're going to need for this, for number 3, is we're going to need to know, first of all, our axis here for L1. That's going to be how we have 20, 30. We're going to have our 75, 65, 55, 45, 35, 25. That's what's going to be on this axis here. And for 2F2, that's going to actually be our DP values, our amplitudes that we're measuring. So for example, if I have at 75, my amplitude is 2, it'd be plotted up here. If at 25, my amplitude is -20, that's how we get that here. But I'm going to talk you through and show you how to do all of this, including the actual noise floor right here. So I'm going to go back to Excel, just like we had in the past one, if I can bring it up. So just like before, I have, again, the frequencies 1 and 2. If you'd rather just do out the, I think for this one it's 1 to 8, so you can do 1, 2, 3, 4, whatever you'd like to do. I just like to be more specific, so I have my frequencies 1 and 2. I already inputted fake values for this. So at my L1 of 75, I have 1. For my L1 of 65, I have 2. Again, I'm just going to put frequency here so you understand. When you're doing this data, it's across decibel levels that you're presenting, not across frequencies. So we're always going to be going horizontally. Just like before, we also will need our noise floor levels. So for L1, when it was 75, my noise floor, I again just pick numbers, and I have that here. Now, in order to do this test, I set this up step by step. You do not have to show all of this information and work. It was just easier for me to do it this way. So first, we're going to average our noise floors just like we did before. So again, we're going to go up to our sigma, we're going to hit average. And again, just like before, I'm going to find a standard deviation. So I'm going to do more functions. My bar should pop up. I'm going to double click standard deviation, erase whatever they have in there because I don't need all of that crazy stuff. And I'm just going to select what I want. So my first and my second trial with different decibel levels. So then I'm going to hit enter. And I have my standard deviation. Now, what I've been doing just to make it easier to show my math, anytime you have Excel to put a function in, you just hit the equal sign. So what I want to do is I want to do 2 times my standard deviation. So if you look, I have F, and then it's F8 will give me that standard deviation. So I can actually write in on the equals F8, and it's going to highlight that. And all I want to do is times that by 2, just so I get 2 times the standard deviation. So times 2, and I hit enter. So that's 2 times my standard deviation. Now, in order to do this also, what you're doing is you're finding an average for frequency. So now I'm going to take this number and add this number. So my average here, so my noise floor average is found in, again, remember you need to put equals in order to do math in here. So my average is found in E8. So I'm going to put in E8, and that's going to highlight my average. And I just want to add it to that math that I did before, my 2 standard deviation. And my phone's ringing, so I'm going to be right back. Okay, just like before. Sorry about that. So now we have our average, we have our standard deviation, we have 2 times the standard deviation. In order to put anything in, you need to put your equal sign. E8 is my average, and we're entering 2 times the standard deviation, or G8. Again, you can select these things. I just find it easier for this to type it in. So I'm going to hit enter. So that's going to be my average noise floor. That's that noise floor in Dr. P's graph. I'm going to come back to it. This is your noise floor line. That's what you're actually plotting, is that average that you just came up with. So I'm going to do one graph for this example. So it is just going to be, all we're going to do is this 8,000 graph. That's it, and we're going to do 2 points. So what you do is you're going to go into Microsoft Word. I'm opening a new blank document for you. So the new Microsoft Word, and let it just be said that I'm doing everything on a Mac. However, I was told that it is very, very similar, no problem. So what you're going to want to do is you go into charts here on the top. You're going to want to do a line, and you're going to want to do a stacked line. It's actually really nice to have a marked stacked line, but it really doesn't matter. I've been doing the marked line ones. So that's going to open a chart then in Excel for me to actually enter my information. So like we said before, what you're going to have on the axis is you're going to have your separate DP values. So this is going to be for, this entire graph now is going to be for 8,000 hertz. So what we had was 75 and 65. So that's what's going to go in first. Those are what your L1 values is. So you'll also have 55, 45 as you go down. Now in these separate columns, what you're actually going to write out is the 2 lines. So you're only going to need 2. So you're actually going to delete the table column, because what you're going to have here is you're going to have your amplitude and you're going to have your noise floor. So for 75, again, you can copy and paste everything, but I've been looking back. So I have on this chart, where were my fake numbers that we had here? Oops, sorry, as I scroll through everything. Downsize that, downsize that, downsize that. Where are my fake numbers? Oh no. Ah, there they are. They're hiding. Okay, so my fake numbers here. So for my amplitude for 75 was 1. So my amplitude for 75 over here is going to be 1. And my amplitude for 65 that I had was 2. So I'm going to enter that amplitude of 2 just for now. For this, I'm actually going to leave these. Actually, yeah, I'm just going to leave these values in for right now, but they don't actually mean anything. Now for the noise floor, this is the part that confused me a little bit. You have to put the same noise floor in every column because it's going to draw a straight line. So based on what I had before as my average noise floor for 8,000, and again, of course, I lost it. All right, just going to downsize everything now. Okay, so what you're going to put in that noise floor for 8,000 is this negative 17.08 blah, 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 blah. Now you need to put that for every single amplitude because it's this standard noise floor plus 2 deviation. So to make this easier just for the example, I'll just put negative 18 in every single column. No, don't add anything, Excel. You're being silly. If you hit enter, it'll normally go to the next line for you. So negative 18, negative 18. And it seems weird that it's going to be the same thing, but remember you're drawing that straight line because you just want to see what the noise floor is to see what's above that. So then you hit enter. Now when you go back to Microsoft, it's now drawing you what it has. So here's your noise floor at negative 18. It's that straight line. Now, in the real world, this is actually going to arc up, or you'll have that divot like before. It was just the numbers we picked. So from here, you can manipulate by changing this, and then you can actually go into the format section, and you can add titles and things like that. You can mess around with the colors and change all of the sorts of stuff, but you are going to want to label your axes, and again, that's an option. You can actually change your layout also. So for axes, I want to name them, I want them. You can also add some lines. Now, here's where the downfall is. In the trend line, there is a linear option and a linear forecast option. That is not what Dr. P wants us to use. He said that everyone did that last year and it messed up everything. So in terms of the graph, I'm going to show you mine, but that's how you input them. So again, the lines here aren't exactly great. What you want it to look like is similar to this. Forget all this silly stuff. All you're going to have is this noise floor line, which is straight across, and your DP amplitudes. Again, you do want to label your L1, so this axis will actually say L1 dBSPL, and your y-axis will say 2F1 minus F2, and all of your plotting. And you will want to label what frequency you're testing. So for this one, we did 8,000. I'm going to bring up my project now. Here's my actual chart for this question. So I do have all of those. What I've highlighted in green is eventually he goes on to ask you about the thresholds. And so I just highlighted what was the threshold for each of those. And in order to find your threshold, I believe what he says is, it is the point where you are greater than 2 standard deviations. So what I did is I looked at my 2 standard deviations. So that one's negative 10.3. And this is the first one that's actually greater than, greater than the noise floor from 2 standard deviations. So here we are. Sorry, I was pointing at the wrong one. So 10.3, I'm at, and again, these are negatives, 2 standard deviations, yeah. So I'm at negative 10.2, I'm 0.1 greater than it, so that was my threshold, because that's when that first happened. So for my second one, my standard deviation was 5.3, so that would be, oh, no, I apologize. We're actually looking at the noise floor plus your 2 standard deviation. You want to find your amplitude when it first exceeds the noise floor by 2 standard deviations. So what you're going to do is you look at this. So negative 10.6, negative 10.2 is the first time it's over that. So that's what I highlight as my threshold. Negative 16, that's below. This is the first time it's above. So that's going to be my threshold. So that's why I have that green there. I'm now going to actually bring up my OAE project that I have so far and scroll down to question 3 so you can see my graphs. So this is the graph that I have it set up. Again, I told you I was preferring frequency 1 and 2. You don't have to do that. But I did keep my chart here. I've labeled everything. Now, for the 1 dB growth line on each plot, if you see this linear one, that's the one it does automatically. So what I'm going to need to do is remove that. However, in order to actually put the plot on, like Dr. P says, he said you can just do it in pencil over it. It's not a big deal. So what you actually do is think about it. For 1 dB, you're going to do 1 dB. So your lines are going to be equal. So if you're at 20, your line is going to be at 20, 10 for 10 and everything like that. So I'm going to have for this one, so at 30, my line technically would be at 30, so I don't have enough space on this graph. At 40, it would be at 40. So that's the kind of thing that he is having you do. So at negative 10, it would be 10, all, etc., just like that. If you go down, eventually your noise floor will get to a point, and he wants you to just analyze these graphs in terms of, is there a notch like this? Are they flowing linearly? Everything like that. But that's how you actually set them up on the Excel program. So just to recap, you're going to enter all of your information into Excel just like before. You're going to find your average, your standard deviation, 2 times that standard deviation, and then add that 2 times the standard deviation to your average. In order to make the chart, what you're going to do is you are going to open up Microsoft Word and hit the chart. You'd like the lines. You are going to put on your y-axis all of your L1 values. Then you're going to need 1 column for amplitudes, 1 column for noise floor. Your noise floor is the average at that frequency, and you want them all to be the same. Okay, moving on to the next question.